one. I may eventually send this out to everybody depending on how far we get in class. So this is number 6. You're given a graph, which you could look at in just a minute on your paper because it actually has the grid on it to where you can actually count things. And then you have this chart. N is 2, 3, 4, and F, like the derivative. This means the second derivative if N is 2. So this is 3, negative 23 halves, and 54. So this means the second derivative, the third derivative, the fourth derivative. All right, so on 6a, you're writing the Taylor polynomial about x equals 0. And be careful that you're writing about f. They tell you that the function has, it says a portion of the graph f is shown above, along with the tangent line, which is this right here. This is your tangent line right here. So therefore I know by default this one's f, which we'll use in just a minute. I need f of 0 plus f prime of 0 times x minus 0 to the first over 1 factorial plus f double prime of 0 times x minus 0 squared over 2 factorial. And they asked for a third degree, so I'm going to say f triple prime of 0 times x minus 0 to the third over 3 factorial. All right, let's find f of 0. I quite literally went here. I went here to, because this is f, so I'll look to see what f of 0 would be. It would be right here. All right, so if you count up on your graph, f of 0 is 3. Then I needed f prime of 0, which would be the slope of this tangent line. If you look on your page, it goes down 2 and over 1. You can actually count it on the graph paper, where the slope of the tangent line, which would be your first derivative, is negative 2x. The x coming from this, but the slope is negative 2. All right, the second derivative at 0 you can find from right here. That means the second derivative at 0 is 3x squared over 2 factorial, which is just 2 times 1. And then the third derivative is negative 23 halves times x cubed over 3 factorial, which is 3. You could just probably leave it 3 factorial, but that gives you 3 times 2 times 1, which is 6. So I would write it this way: 3 minus 2x plus 3 halves x squared. When you multiply by this reciprocal, you get negative 23 twelfths x cubed. And that's the answer to the first one. The B part, right, the first 3 non-zero terms, that means sometimes terms turn into 0, and you've got to just keep going until you have 3 of them, is what that means, of the Maclaurin series for e to the x. So hopefully you have it memorized so you don't have to reinvent like f of 0, f prime of 0, and so on, as 1 plus x squared over 2 factorial is the first 3 non-zero terms. They wanted you to write that out to get you thinking about how to write a second degree Taylor polynomial for e to the x times f of x. So I'm going to use the polynomial for e to the x, which is 1 plus x squared over 2 factorial, which is 2, times f of x, which we found right here. 3 minus 2x minus 3x squared over 2 minus 23 twelfths x cubed. All right, now I'm going to do FOIL, but I've got to make sure I answer their question. They want the first 3, they want a second degree Taylor polynomial for this product. So I only have to get to the second degree. So let's just distribute the 3 and see what happens. That gives me 3 plus 3x minus plus 3 halves x squared. All right, so that's good. Now let's distribute the negative 2x. That gives me negative 2x. This gives me negative 2x squared. And I don't want this one because I'm not going to even use this one. I'm not going to even use this one because that will give me an x cubed. So let's go to this one. That gives me plus 3 halves x squared. I'm looking for a second degree. Once I do this, I'm going to go over second degree. That's going to be x cubed and x to the 4th. And I don't need anything. I certainly don't need that one for a second degree polynomial. And so I have 3. I have 3x minus 2x is plus x. 3 halves x squared, and 3 halves x squared is 6 halves x squared, which is 3x squared, minus this 2x squared would give me a positive x squared. And so that's what would happen if you multiplied e to the x times f of x. Okay, now the c part, they asked me to actually integrate f that I found in a. So h of x is equal to the integral from 0 to x of f of t dt. So if I integrate this and then fill in top and bottom, I get h of x. All right, so the antiderivative of f of t dt, pretending like this is a function of t for a minute, would give me 3t minus 2t squared over 2 plus 3x cubed over, okay, I did 3x, or 3t, minus 2t squared over 2, I'm following my variable, minus 3x cubed over 2 with another 3 down there. That's going to give me a 6 if you add 1 and divide by 3. And this one's going to be minus 23x to the 4th over 4. It goes down there with that 12, so that gives me a 48. Sorry, these are t's right now because I just integrated f of t. And it's going from 0 to x. So I fill in the top. I get 3x minus 2x squared over 2. Which is just minus x squared, so let's just have that here. Minus x squared plus x cubed over 2 from this, minus 23x to the 4th over 48. And then they wanted me to find, that would be h of x. Is approximately equal to this. All right, so I'm going to squeeze it in down here so I won't have another slide so you can see it all together. So I'm going to say h of 1, using this polynomial, is approximately equal to, this is a 1, 3 times 1 minus 1 squared plus 1 cubed over 2 minus 23 over 48 times 1 to the 4th. And I'm sorry that squeezed in, but that's 3 minus 1 plus 1/2, that should be plus 1/2. Let me make sure that's right. Yes, 3 minus 1 plus 1/2. Yeah, which is right. And then minus 23/48. When you get a common denominator and add all that together, your answer to C is 97 over 48.